All right, let's get going. So welcome everybody to this speaker series event with Matt Kaeberlein. I am Linus Peterson, co-founder of the Swedish Longevity Cluster, which is an organization with the goal of kickstarting the longevity industry here in the Nordic countries and in Stockholm in particular. So the goal of the Swedish Longevity Cluster is to really make this take off here in the Nordic countries. And since we launched in September of last year, we've had two pitch events, two pitch nights. We've been featuring one of the major newspapers. We've had one major conference together with the Longevity Biotech Fellowship in January, where we had 60 researchers, entrepreneurs, investors from 20 different countries come here and trying to advance the field of longevity. And we are just getting started. So this is great stuff. This speaker series is a series of talks, as the name suggests, by leaders within the longevity movement. So researchers, CEOs, entrepreneurs, thought leaders, innovators. They are free and open for all, a public good to the global longevity community. Yeah, and we're really happy to be able to do this. We've had in the past Nathan Chen, Aubrey de Grey, Patrick Burgermeister, and Mark Hämäläinen. And today, of course, we have Matt here. Very happy about that. Next time, we have Sara Hägg, one of the leading scientists in the world when it comes to measuring aging. We also have Emil Kentsiora and Sebastian Brunemeister, as well as Alexandra Stolzing later. All right, that's enough for me. Let's move on to introduce Matt. Matt, you are one of the top aging researchers in all of the world. It's an honor to have you here.
Depends on who you ask.
It's my subjective judgment. You are the CEO of OptiSpan. You are affiliate professor of the University of Washington, co-director of the Dog Aging Project, and you have authored over 250 scientific papers. So this is really a great accomplishment. And when we spoke about this before, you've held a lot of talks, so you preferred more of an interaction type of setting. And I think this is great. It's actually more fun. So let's get right into it. I've prepared a few questions, and we can just have a lighthearted discussion. And after these questions, we're going to open up to anyone listening in or anyone here in the room with us to ask questions. All right.
That sounds great. So thank you, Linus. And I just want to say, I think what you're doing there is very important, and I'm a big fan, and I'm happy to be here and able to participate. So great job. Keep it up. Hopefully, sometime in the near future, I can get to Sweden and be there in person.
Wonderful. That's lovely to hear. Thank you so much. All right. So the first topic, MTOR and Rapalogs. So you published some on this topic.
Yeah.
What we're sort of thinking here is that the longevity industry is like full steam ahead, but it's hard to get a clear picture of like how far in the development process we have come. So in your judgment, how close are we to something actually, getting approved by the FDA and hitting the markets?
So I think if you're talking specifically about mTOR inhibitors, I mean, we already have rapamycin, which is FDA approved and on the market. It just is not approved for longevity, right? So I think I'm going to try to answer this question in two ways, right? One is sort of I think the general question is, how soon will we have a geroscience intervention, a drug presumably that gets FDA approved for a geroscience indication? Could be lifespan, won't be lifespan in people, could be a health span metric, right? That's I think the bigger question that the field is sort of grappling with. When we talk specifically about mTOR inhibitors, maybe we can come back to this, but as I mentioned, we already have a drug, rapamycin, that is FDA approved and is being prescribed off-label, and people are using rapamycin for potential health span benefits right now. And so I think with rapamycin in particular, there's no real incentive in general for further development of rapamycin by pharmaceutical companies for new indications. So really what we're seeing are people starting to do clinical trials like Jonathan Ahn's clinical trial for periodontal disease, Yu-Shin Su and Zev Williams trial for premature ovarian failure. Brad Stanfield is working to have a clinical trial for muscle function in the elderly with rapamycin. I think we'll see more of those kinds of, I guess, academic clinical trials as opposed to pharmaceutical companies going for new drug indications. And it's probably worth mentioning, we are also seeing those kinds of clinical trials for other interventions. There's a whole host of small clinical trials for different senolytics that are being done more or less on the academic side. So I think we're starting to see geroscience clinical trials in that space. The question of, when will we have the first FDA approval for a geroscience drug for a geroscience indication is harder to answer. I think that probably the first lifespan approval will happen in companion animals. Probably most people on this call are familiar with the company Loyal, which is developing a drug for FDA approval for longevity in pet dogs. I think there's a reasonable chance they will get conditional approval next year for that drug. So if that happens, that will be the first FDA approval for a geroscience drug for longevity or for a geroscience indication. I think on the human side, probably within the next 10 years, we will have the first FDA approval of a geroscience drug. What the endpoint will be is a longer conversation. I think there are probably, a half dozen or a dozen different endpoints that different companies are looking at. And they may not be endpoints that are pure geroscience endpoints, meaning it's not going to be longevity. It may not be a functional improvement in healthy people. It may be a more traditional disease endpoint, but everybody's going to know that that intervention was developed as a geroscience intervention to target the biology of aging.
Oh, cool. And would you care to speculate on like the this is hard to know in advance, of course, this is why we do studies, but how big could the effect be?
Well, that's a good question. And again, it's going to depend on the endpoint that you're talking about. So let's just talk about the case in dogs with Loyal or with rapamycin, because there I think it's easier to get to an answer where we can know the answer in a reasonable time frame. So if we look at the effect of rapamycin in laboratory animals, and we'll stick with rodents right now, mice and rats. We can anticipate up to about a 25% increase in average longevity with something like rapamycin. It might be possible to do better, but nobody has done better so far. So I don't think it's unreasonable to think that you could get a similar size effect with Rapalog, with rapamycin, or in the case of Loyal, they're targeting the IGF-1 pathway, insulin-like growth factor 1, which is also a well-studied, well-known pathway in the biology of aging in laboratory animals. So it wouldn't shock me if we can see 20, 25% effects on lifespan, especially in large dogs. I think it's an interesting question whether or not the magnitude of effect for something like rapamycin or an IGF-1 inhibitor, growth hormone, something that reduces growth hormone signaling, will be smaller in smaller animals, like smaller breeds of dogs, which already age more slowly and live longer. But I think 20% is reasonable. So that would, if we're talking about a dog that would typically live to be, 12 years, that's another 2.5 years of life expectancy. And the expectation is those would be healthy years of life expectancy. In fact, this is another question that often comes up. Are these interventions really prolonging health span, prolonging lifespan? Are they doing so proportionally? Is it having a bigger effect or smaller effect on health span? I don't think we know the answer to that quantitatively. My impression is from the studies in laboratory animals that you get a bigger proportional increase in health span than you see in lifespan, at least with rapamycin. And I think that's probably true with the other types of interventions that are most commonly being studied right now, meaning that if you get a 2-year, 2.5-year bump in lifespan, maybe you get a 3.5-year bump in health span. That's speculation, but that's kind of my feeling from having seen the data and having done some of these experiments in my own lab. So if you're asking me how much we can expect to see in humans, I don't know. I would like to think it's going to be linearly proportional, but I also think you can make a plausible argument that the magnitude of effect is not going to scale linearly, and maybe a 20% effect in mice will be equivalent to a 5% effect in humans. I really just think we don't have much in the way of data to really support either side of that argument at this point.
Mm-hmm. Very interesting comment. Thank you so much. Yeah, let's move right along. You touched upon this right now, of course. But for those who are not familiar with it, would you please talk a bit about the dog aging project? And there recently has been some controversy of the funding getting where there's uncertainty of the funding. So what's the status right now? Yeah.
Sure. Yeah, so I'll start with the sort of general introduction to the dog aging project. So for those who maybe aren't familiar with the dog aging project, this is a project that Daniel Promislow, Kate Creevy, and myself really started about 10 years ago. So it was really right around 2013, 2014, where Daniel and I were talking a lot about the potential for companion dogs, pet dogs, living with their owners as both a model to study the biology of aging and also as a place where we thought we could really have a significant impact on health span and lifespan in a socially relevant animal. And by socially relevant, what I mean is the statistics tell us that, and this number is getting larger, 50 to 60% of companion animal owners, or what people are now calling pet parents, because owners has sort of a negative connotation to it, that 50 to 60% of pet parents consider their companion animal to be part of their family. So it is obvious to me that if we are successful at increasing health span and lifespan in companion animals, that has a big social impact, independent of what we learn about human aging. So we started talking about this a lot, like I said, in 2013, 2014, officially started the dog aging project. And by officially started, I mean built a website and bought the URL. That's about as official as it got. In I think 2014, with the idea of creating what we call a longitudinal study of aging. All that means is observational, following dogs in this case over time, capturing as much data as we can about the environment, the genetics, the diet of those animals, and really trying to understand what are the most important determinants of health span and lifespan in dogs. We also, at the same time, envisioned a clinical trial, actually a series of clinical trials, but really a singular clinical trial at first of rapamycin to test the hypothesis, does rapamycin increase lifespan and health span in companion dogs? So we, as I said, started the website in 2014. I scraped together a little bit of funding to do a small kind of phase 1 equivalent, phase 2 equivalent clinical trial of rapamycin in dogs starting in 2015, 2014, 2015. And it really took about 5 years to get significant funding through the NIH to support this idea. So it was a lot of work. People thought that I was crazy for the first few years, or at least that's what they told me. I think everybody recognized the power of this idea, but nobody thought it was possible. And so it really took until 2018 until we got a large NIH grant to build the longitudinal study of aging. That's when we really created the infrastructure for this project. And by 2019, we had about 20,000, 25,000 dogs and owners enrolled in the project. We were really at that point just starting to enroll dogs into the rapamycin kind of phase 3 pivotal equivalent. Again, we're not going for FDA approval. It's already an FDA approved drug. And then, of course, everybody knows what happened in 2020. COVID-19 came along, the clinics all shut down. So instead of really focusing on building out the clinical trial, we just really tried to strengthen the infrastructure and enroll more dogs into the observational side of the project. We're now up about 50,000 dogs in the dog aging project. So it is without a doubt the largest longitudinal study of aging in the world. And have gotten a lot of really interesting and powerful data, published more than 50 peer-reviewed publications. And we're now up to probably 150 to 200 dogs enrolled in the rapamycin clinical trial. So I can talk more about the clinical trial if people are interested in the details there. But it is, again, designed with lifespan as the primary endpoint. It's randomized, double-blind, placebo-controlled. But of course, we're looking at as many health span metrics as we possibly can. So all of this is just to kind of set the stage for the question you asked about the funding situation. So NIH grants are 5 years. So the grant was first funded in 2018, towards the end of 2018. That 5-year period ended in 2023. I think everybody on the team anticipated the grant would be refunded, since we were originally proposed to enroll 10,000 dogs. We'd enroll 50,000 dogs, published 50 plus papers, exceeded every possible milestone or metric of success any reasonable person could ask for. It wasn't refunded because of, I would just say, bureaucratic incompetence, kind of the nicest way I can put it. So we are in now a period where the project is kind of in a bridge period. And I think there are plenty of people to blame, including people on the team and myself, who probably could have presented the success of the project better. I don't want to get into the blame game. I will say the staff at NIA is very supportive of continuing to fund the project. They have encouraged resubmission of a new grant that they're going to do their best to help us get funded. So I think that is likely to happen in about a year. But the problem at NIH is there really is no mechanism when things go off the rails like this to rapidly ensure continuation of a project. So we being Daniel, Katie, myself, the rest of the members of the team, have been really actively working on philanthropic funding to kind of bridge the gap. I personally would like to be free from needing NIH funding at all, just given the vagaries of that whole process and issues there. But at least to bridge the gap, we are really trying hard to create a philanthropic campaign. So we are actually just in the process of rolling out a platform for this philanthropic campaign. We have created a 501c3 nonprofit institute called the Dog Aging Institute. You can go to the website now, dogaginginstitute.org. We can accept donations in the United States. Those are tax deductible. And then we are working with a group called Kernels, or also rebranding as Donor List, which is a crowdfunding platform with kind of a unique model where individuals and organizations can become champions and amplify the campaign through their own social networks. So that will be happening in the next week or two. So if anybody is interested in helping to support the project, I would be grateful for any and all support. The good news is that we have gotten matching commitments to keep the project alive. So we need about $1 million to just keep people employed and keep the infrastructure going until we anticipate the next round of NIH funding, which would be best case scenario, probably June of 2025. So we've gotten matching funding from two major donors to support the project at that level. So that's the good news. So the project is not going to die, which is great, because there was concern for a while that might be a challenge. But that also means we're not going to be able to do any science. So that's really just keep the lights on level. And that also means that the rapamycin clinical trial will be on pause for enrolling new dogs. And as probably all of you can appreciate, when you put a very, very large project like this on pause, that creates a lot of complications with, we have 20 plus clinical sites around the United States. Will those sites still want to participate if we can't keep enrolling dogs? I'm concerned that this will be a real problem for the clinical trial in particular if we're not able to do more than just keep the lights on. So that's why, I'm very much working hard to have this continued push to raise philanthropic funds to help us move forward. So that's kind of the status right now. So again, good news is project will at least be alive for another year. Bad news is that there's no guarantees on NIH funding at this point in the future. And it's kind of a minimum keep the lights on status right now, but I'm optimistic that we'll be able to do better going forward.
All right.
And happy to go into any more detail if people are interested in the Q&A.
Sure. Yeah, you already answered my question. What can we do to help? And this sounds awesome. We're gonna try to amplify your campaign to.
Thank you.
Yeah.
Yeah, and
Definitely.
I'll share the information with you, Linus, once the crowdfunding campaign is live, and then again, I would be grateful to anybody who can help us promote that campaign through their networks.
Awesome. Please do so. Yeah, I think this is a very important project. I mean, this is dogs are mammals, obviously, and they're probably more like us humans than rats, evolutionary speaking. And, it's
Yeah, and
just
I think it's sort of an unfortunate situation the way this played out. As I said, I would care. I don't think there was any bad intent. I think it was just a series of missteps and a lot of bureaucratic challenges with NIH. But it's very frustrating, I think, for a lot of people because I think many people in the field recognize the importance of this project, both from a scientific perspective, but also from a public relations perspective for the field. And you know, I have had very, very few comments, and trust me, there are always people who will make comments out there that suggest that the project has not been successful so far. So it almost boggles the mind that you could get a group of peer reviewers together that would not refund this project. It's hard to understand. It's very, very difficult for me to understand, what they were thinking.
Mm, I hear you. All right. Well, best of luck. We will help as much as we can. Moving right along to another very exciting topic. So, Aura Biomedical, your other company, which you are co-founder of, and you have launched something called the Million Molecule Challenge. So, for those not familiar, would you please have a very short just explanation of what is this company doing and why is it important and how can we
Sure.
help?
Sure. So, yeah, so you said very short. I struggle with very short. I'll do my best. But I think it's useful to give a little bit of background on why we would even want to do the Million Molecule Challenge. So, really, this idea, so the Million Molecule Challenge is what it sounds like, more or less. It is a proposal to test a million interventions for their effects on lifespan. In this case, in C. elegans. Why lifespan? Because if you're interested in finding longevity drugs, lifespan is the phenotype you should look at, in my view. So that's really the goal, test a million interventions. Why would we want to test a million interventions? And this really stems from my view, and I've held this view now for more than a decade, that if you take a truly, blinders off look at progress in the field, there's been a lot of mechanistic progress in understanding the biology of aging. But if you look at the effect size of longevity interventions, they have not gotten bigger over the last 40 years. I would encourage everyone to go look at the paper from Rick Weindrich and Roy Walford published in, I think, 1986 in Journal of Nutrition on caloric restriction. They showed a 60% increase in lifespan in mice from caloric restriction. Nobody has done better since then, as far as I know, with a non-genetic intervention. If we are really getting closer to longevity escape velocity, as some people like to suggest, why aren't we seeing new interventions of larger effect size on longevity every year, or at least every 5 years? I think this is a real reflection of stagnation in the field, and I think that's at least in part because people have gotten so focused on mechanism and the hallmarks of aging that nobody is really looking outside of the lamppost to find new things that have large effect size, whether that's combinations of interventions we know about or new interventions. So that was my thinking 10 years ago, and that led me to ask the question, well, if nobody is looking, why aren't they looking? And I think one of the reasons is it's hard work. Measuring lifespan costs a lot of money and it takes a lot of time, regardless of what organism you do it in. It requires a lot of tedious manpower, even if you're working in C. elegans or fruit flies. So basically, we created this technology to address a limitation, which is to automate as much as possible the ability to measure lifespan. And in thinking about what organism you work in, C. elegans just seemed like the right mix, in my view at least, of confidence that some of the mechanisms translate to humans, or at least to mammals, to mice. Of course, humans are mammals. That there's some reason to believe that some of the mechanisms are shared. I think there's no question about that. And then the ability to actually scale this to a level that could make a difference. And so we created an automated system called the WormBot that basically takes 95% of the human labor out of the lifespan assay, and it couples a robotic system for image capture and artificial intelligence to automate the lifespan process. So we created this technology. We've developed it over the last several years. As is often the case, it's difficult to get funding through federal agencies to do what people call fishing expeditions. Fishing expeditions meaning you don't have a mechanism proposed or a hypothesis. You just want to see what the biology tells you. So couldn't ever really get traction with NIH to do this. So we decided to spin the technology out of the lab as Aura Biomedical. So that's what we've done. We've created this company, Aura Biomedical. I'm not an employee of Aura Biomedical, but my offices are really right next door to them. So I see the guys pretty much every day. And of course, I'm a co-founder and on the board of directors. So I play an active role in really trying to push the science forward at Aura. And so we've launched this Million Molecule Challenge as, to some extent, a crowdfunding campaign. So the idea being that we give the community an opportunity to participate in this by nominating interventions and financially supporting the testing of those interventions in a way that then allows the company to put that data into an open access database that can seed future discovery in the field. So I think there's lots of value in this open access database. One of the reasons why I really would like to see this database get up to 100,000 interventions or so is because right now, if you go to DrugAge, I think they've got about 2,000 interventions, period, that have ever been tested and annotated and put in a single open access place across all organisms. Again, that kind of boggles the mind that the sum total of data in this field over the last 50 years amounts to about 2,000 interventions being tested. There's more out there, of course, but come on, we can do better than that, people. So I would love to see us having a database of at least 10,000, 100,000 would be great. One of the reasons why that's valuable, though, is there are a lot of people who recognize the power of AI and how it can hopefully accelerate discovery in the field. The problem is, if you're using AI to identify new interventions and you're training it off of rapamycin and metformin, guess what you're going to get out? So we really need a much larger training set, a high quality training set, which, by the way, a lot of what's in DrugAge is not high quality. We need a high quality training set so that we can actually take advantage of these AI tools to, in a very powerful way, predict new interventions. And so that's one of the big values I see to a large open access database that anybody in the field or outside of the field can play with and use in a variety of ways. That AI-based intervention discovery is just one possible idea there. So this is a community-based project where people can go to the Aura Biomedical website, pick interventions, can be single drugs, combinations of drugs, and help support the creation of this open access database. Right now, it's been limited to FDA-approved drugs, but really, the technology is agnostic to the type of intervention, as long as it can be done in C. elegans. So it could be natural products, could even be gene therapies, but we need some resources to actually be able to branch out into those other domains. And so if there is appetite in the community to support this kind of a project, we can do it. And so if anybody has ideas for larger approaches that they're interested in, I would certainly encourage you to reach out to Mitch and Ben at Aura, and they would love to talk to you about how we can accelerate this and amplify.
Oh, that's awesome. I love how you involve the community. Anyone, anywhere can just sort of order one of these tests. And, yeah, I'm part of science, as citizen scientists. It's really amazing. All right, so we're gonna put your analytical skills to the test here. I actually I have bought one of these tests, and I chose the molecule vanilla, since my little sister is a biologist and she did some field work in Madagascar on the vanilla plant. So I'm like, hey, I gotta test this, and you can imagine the headlines: vanilla ice cream, good for your
yeah.
So this is the
all right, you got a winner.
Yeah, it's kind of fun. So at least it's better than the control. Yeah, this is just for fun,
Yeah, no. I mean, it is, but it's also for science, right? I mean, again, this is actually the kind of valuable data that once you have 100 things that have this kind of an effect in a database of 100,000, let's say, wouldn't even be that big. Then you can really start to do some predictive modeling on maybe what sorts of combinations would give much larger effects. So anyway, did you have a question about this, or do you want me just to comment?
No,
Because I mean, it's
just a fun
yeah.
side note, basically.
Yeah, I
Yeah,
mean, I haven't looked. I mean, now all of a sudden my biologist brain is kicking in and I'm like, what's the mechanism here? What do we know about vanillin and how it might be working? I mean, it's interesting, right? So, the other thing that I think an open access database like this can do is, so Aura is a company, right? Aura is not an academic lab trying to understand mechanisms other than if there are specific interventions that Aura is going to take forward and develop in the for-profit space. So an open access database like this, immediately, C. elegans researchers can look at this and be like, oh, this is cool. I want to study it and figure out the mechanism. Is it DAF16 dependent, for example? That's kind of the first question I always ask with a drug that extends lifespan in C. elegans. Is it working through the insulin pathway? Very clear genetic experiment that somebody can go do now because this is now available in the public domain. So I think that there's a lot of benefits to putting this kind of data out there, even for you, even though for you it was just a fun experiment. There's a lot of value to the field to putting this kind of data out there.
yeah, exactly. Yeah, definitely. Yeah, so this is great stuff. We're moving right along. There's so many interesting topics here. So you have another company, next
Right.
in.
My day job.
Yeah. So yeah, just wanted to give you sort of a chance to speak about this, like what's the goal of the span and what are you trying to achieve? Yeah.
Yeah, sure. And so again, maybe it's helpful to give a little bit of background here. So I think probably everybody on the call, if you're not aware, I spent about 20 years at the University of Washington as a professor of lab medicine and pathology, running a pretty large research lab studying the basic mechanisms of aging, right? And about 3 years ago, this is probably just before the pandemic, I kind of started to recognize I was a little bit burnt out in academia and started looking at, other opportunities, options that, would be kind of re-energizing for me. And I took a look at a couple of existing companies, but this was probably in 2021, got introduced to a guy named Dave Saby, who owns Saby Corporation, which is a large real estate data center company, and George Haddad, who is our chief medical officer at Optispan. And so Dave, George, and I, really realized we were very much aligned around the idea of what Lee Hood would call scientific wellness. And Dave knows Lee Hood very well. For those of you who don't know Lee Hood, he's a very famous scientist in systems biology, started the Institute for Systems Biology in Seattle. Actually just had a book come out with Nathan Price on scientific wellness, which is fantastic. I encourage everybody to check it out. So Lee is a real leader in thinking about how science and systems biology can be applied to health span and longevity, even though I don't think he would consider himself a longevity scientist. So all of that is to say that Dave and George and I, with the influence of Lee, recognized that there were real opportunities in people now to have an impact on health span. And some of that is the biology of aging. I think everybody on this call probably agrees that the biology of aging is, number one, the greatest risk factor for nearly every major cause of death and disability in people. And that by targeting the biology of aging, we have real opportunities to at least improve health span, if not improve both lifespan and health span in people, even given what we know today, and certainly with what we're going to know 10, 15 years from now. So we all aligned on that philosophy and really started trying to think about what can we do now, given the tools and technologies that is science-based, evidence-based, to maximize health span for as many people as possible. That's really what Optispan is all about. And so that is our mission, overarching mission. And then when we think about what can we do now that's potentially scalable, that can impact a large number of people, we're really focused in two domains right now. And we're not limiting ourselves to those two domains, but for right now, we're focused in two domains. One is sort of very high-touch clinical models. So this would be similar to what a lot of people are calling concierge medicine, longevity medicine. I'm a little bit unsure about that term, longevity medicine, because a lot of people have co-opted that word, and they're not really doing what I would consider high quality or science-based medicine. But the idea is, if we think about, if let's just say money is no object, right? Then what would you do that would give people the best opportunity at maximizing healthy longevity? That's what we're trying to build. And so we have a clinical program up and running. We call it our Trailblazer program. I would say it's on par with the highest of the high-end concierge models that are out there. But our focus is really 100% on science-based health span optimization. And then we're also looking in the corporate world. So at the level of sort of a corporate wellness model, again, I'm not a huge fan of that phrase, corporate wellness, because a lot of people has a negative connotation, but corporate, let's just call it corporate health span program. What can we do there at a lower price point that maximizes the effectiveness of this health span optimization approach? So I know I'm being very vague. To put a little bit of detail around it, I would say 75% of what we're doing is not biology of aging, at least directly, not in the way probably most people on this call are thinking about it. It's much more around advanced screening, prevention, lifestyle modification, and to the extent that people have pre-existing conditions, pre-existing disease, treating that disease, making sure that that doesn't limit their longevity, right? So a lot of it is about early detection and trying to put people, if they're not on a optimal, I don't even really like that word optimal, so I don't know what it means. I mean, I know what it means, but I don't know how we get there in terms of health span, but I'm going to use it anyways. If they're not on an optimal health span trajectory, how do we get them closer? A lot of that, as you can imagine, is going to be lifestyle modification. Now, I did say that 75% of what we're doing, 80% of what we're doing is not biology of aging. I want to reframe that a little bit, because I do think it is important to appreciate that the reason why lifestyle works so well in terms of health span and longevity is precisely because lifestyle intersects with the biology of aging. We know a lot about how optimal nutrition impacts the biology of aging, exercise impacts the biology of aging, or sleep quality impacts the biology of aging. So even though we're focused on lifestyle, I think the reason why that focus on lifestyle has such an outsized impact is because we are, in fact, affecting biological aging. But it's not the kinds of things that most people in the longevity field think about when you talk about rapamycin, metformin, NAD precursors, other potential longevity interventions. That's not our primary focus, although we are looking at, in addition to the sort of traditional kind of diagnostics, pre-screening approaches that we're using, we are looking at multiple different modalities of various hallmarks of aging. I'm getting a little bit of noise, so somebody, if you're not on mute, if you put yourself on mute, that'd be great. As part of our program, but that's more to learn of these various clocks or other biological aging modalities. Where are they useful? How well do they track with the other kinds of biomarkers that we feel more confident are predictors of health outcomes in the future? How can we use them in the most effective way? Much of what we're doing is trying to determine that. Also, a big part of this is collecting a large body of data where we can do our own internal biomarker discovery to move towards more effective and accurate assessments of current health status and future health risks.
Okay, cool. Very interesting. There are a lot of companies. We have a bunch of them here in Stockholm as well. We're trying to sort of extend health span, and doing kind of.
And I will say, yeah, there are a lot of people out there in this space right now, and I think that's good. I think that there's a huge need. I've been fortunate that I've had the opportunity now to talk to a lot of people about their feelings about their own healthcare. And one of the things that often surprises me is even the people who you would think have access to the very best healthcare in the world, very, very few of them appreciate it. Most people, the vast majority of even the people who have access to high quality healthcare are dissatisfied with their healthcare. Maybe that's a little bit different in Sweden and other European countries, but in the United States, almost nobody is getting good quality healthcare. So there's a huge opportunity here, and there is room for lots of people to explore in this space. I think the real challenge is, and this is true of I think the longevity space in general, that it's very hard to disentangle the signal from the noise. There's a lot of noise out there. There's a lot of people, I would say, with questionable motivations and non-scientific approaches out there that create a lot of confusion, and that's a real challenge. And so, one of the things that we're trying to do at OptiSpan is to identify like-minded partners who we feel confident in, both on the provider side and also in companies that are trying to offer these kinds of services, create new diagnostics, new tests, that where we can create a network that has been somewhat vetted so that we have a trusted source for a lot of this information, because this is going to be even more important as we go forward. I know people who've been in the longevity bubble for a while feel like it's gotten huge, but I think we're just really at the very beginning of this, acceleration in interest and enthusiasm for this space. And so it's going to get even more and more exciting, confusing, noisy over the coming few years. There's going to be a real need for credible voices, and we're trying to help facilitate that as well. But I think there's lots of rooms for lots of winners in this space, and so I'm enthusiastic about the number of companies and providers and scientists who are kind of moving in this direction of, how do we bring some of these discoveries to people as quickly as we possibly can in a responsible way?
Oh, that's wonderful. Wonderful. So I have a lot more questions, but I don't want to monopolize the time. So if anyone on the call, if you have any questions, now is the time. Please just shout them out, or you can write them in the chat as well. Or anyone here in the room, if you have any.
I have one question, Matt. Great talk. When it comes to the longevity space, it's like a big longevity jungle out there, and it's quite hard to navigate in this jungle in a good way. Do you have any good principles or which can be used to navigate in this jungle?
Yeah. So thank you for asking, Krister. That you kind of set me up. So one thing I will say, I'm sure some of you know that we have launched a podcast on both YouTube and some of the podcast platforms called the OptiSpan podcast. So I hope that can be at least a contributor to navigating the jungle. We are trying really hard to, obviously a lot of it's my opinion, so take it for what it's worth, but trying very hard to present a clear-eyed view and scientific view of some of the questions, challenges, controversies that come up. So I hope that's at least one source of credible information that people can turn to. So check it out on YouTube, OptiSpan podcast, and please consider subscribing if you like the content. So there's my plug for that. I think more broadly, though, it's hard. I don't have a great solution other than to say that I think that trying to find voices who are measured and reasoned and don't, make bombastic claims, I think is important. I think people are going to have to use their own discretion a bit, but I would say, you want to find sources of information that don't present one size fits all solutions, that don't talk about, the latest, greatest thing as if it is, revolutionizing the field. I mean, one way I think about it is, I mentioned this 40-year-old experiment from Weindruck and Walford, right? If people are jumping up and down talking about immortality or longevity escape velocity, and they can't address that fundamental point that I made, that nobody has done better than that experiment in 40 years, my advice would be probably stop listening to those folks. I think people should take a more realistic view. And again, I'm not trying to say that there aren't exciting, important discoveries happening in the field every day. There are. But I think we need to have a realistic perspective of where the field is at and where we're going if we're going to actually achieve many of the goals that many of us want to see the field achieve. I don't think it's helpful to be out there hyping things that shouldn't be hyped. So that's my personal view. Again, but there is no easy answer to how you wade through the noise, unfortunately. It's going to be a challenge going forward. And I think we're all going to have to learn how to navigate it.
Critical thinking is still important. To build on this question, I actually would you care to weigh in on the supplements?
Well, no, I would say people can go watch the episode if you want my opinion. I mean, I'm happy to answer any specific questions people have about supplements. I would say, I mean, I think this quote here, which I think is true, that there is no supplement that has been proven to have anti-aging effects in humans. I mean, again, that's just data, right? I don't think anybody can really argue with it. I think the question generally around supplements and things like rapamycin or metformin or off-label use of other prescription medications is every person has to do their own sort of risk-reward analysis, right? And so I think what I tried to do with this episode on the podcast is help people think about how you might approach that type of risk-reward analysis. And I talked about how I approach it. But that's the way, and again, this gets back to critical thinking. How do you do a risk-reward analysis? Well, you have to start with being informed, right? You have to know, how do you estimate the risk and the reward from whatever it is that you're considering doing or taking. So those are the kinds of things that I try to communicate, is not so much around my own opinion, because it's only my opinion. Again, take it for what it's worth, but more, how do you think about this for yourself as you're trying to evaluate what you might take or what you might do to optimize your own health.
Cool. Thank you very much.
May I chime in with a question as well?
Please go ahead.
Thanks, Matt, for doing this. And I think building on the previous question, you have, to me, been very impressive in kind of walking this fine balance of communicating science in a professional way, but also in a way that people can understand who don't have the scientific background. I understand that is fairly difficult. And I also agree with you that quite a few people kind of, after a while, they start drinking their own Kool-Aid, so to speak, and then they become famous, and that's perhaps a challenge. And they lose credibility, etc. And I don't want to go down that track. I would rather go down the other track. So as I think you are very good at doing this, who do you think are good at doing this? Who would you recommend apart from yourself?
Yeah. So, I mean, people have different feelings about Peter Attia. Peter's a friend of mine, so that may be clouding my view. But I really think among the more popular sort of influencers out there, I think Peter is one of, if not the most credible in the space of, medical longevity, right? So that he talks a little bit about science of, maybe more than a little bit, the science of longevity. But I really think where Peter's, laser focus is, and where he really does a lot of good, is in how do we take what we know now, how do we think about it in a critical way, and how do we apply it for individual health. So I would recommend Peter probably above anybody else in that area. I think, again, we can all disagree about specific conclusions that we reach, and there are maybe a few that Peter emphasizes more than I would personally. But I think that approach of really trying to evaluate the data, think about it in as unbiased a way as you possibly can, and then reach conclusions based on that, I think he does better than almost anyone else. So I'd point to Peter. I personally like Brad Stanfield's content. Now, he's a little bit YouTube-y for me, and our podcast is a little bit more YouTube-y than I'm super comfortable with as well. That's just my personal sort of, feeling on how I get you have to present it that way on YouTube. But I think Brad does a pretty good job of interpreting the research and, again, coming to conclusions. I don't always agree with his conclusions, but trying to come to conclusions that people can apply in their own daily lives. And so I like his content, although sorry, Brad, but I would put Peter up here, and then Brad maybe the next tier down. Other than that, honestly, I'm not a huge consumer of content in the longevity or wellness space on a regular basis from individuals. If there's a topic that I'm interested in, I'll go do a deep dive on that. But I don't really watch a lot of other, influencers on a regular basis, and so I don't want to comment or recommend anybody else. I also don't want to bash other people, so I'm gonna stop with that. And then if anybody has specifics they want comments on, I'll try to navigate that.
Cool, thank you. I will continue with one kind of interesting question. I don't know, are you familiar with the Longevity Biotech Fellowship with Nathan and Mark?
Yep.
Awesome. Yep. Cool. So just two questions here. The first is, so Nathan and Mark are very impressive, and they have sort of, especially Nathan, I feel, have articulated the goal very clearly, and that is to have indefinite lifespan. So he's sort of a maximalist position. So if you have sort of a lifespan, a health span debate, so they are definitely in the lifespan camp, indefinite lifespan. So question one is, what's your take on this? What's your goal, basically? And secondly, they have, I don't know if you read this, but they have done a very interesting survey of the field. Perhaps they have asked you as well, I don't know. And they've created this longevity bottlenecks report, where they have actually asked, I think it's like 400 researchers and entrepreneurs and investors within the field. And they asked them, like, what's the maximum impact you believe that your current research will have on extending lifespan in humans? And you can see I've sort of cut out the figure here. But this is, when I read this is kind of depressing, because it's like the mean, I mean, it's like 10 years, 20 years maybe, who are like, yeah, if everything goes perfect, my line of research can extend lifespan like 20 years maybe, and more realistically 10 years. And to me, I share Nathan's and Mark's sort of goal, like a maximalist position. So I'm kind of depressed here. And I think we should, yeah, we need to think differently here. Yeah. So what's your take on that?
Sure. So first thing I would say is, I think and again, I don't even know that putting them in health span and lifespan buckets is the right way to think about it. But the idea of what I would say, we clearly have opportunities for 20 years. I think that's reasonable in people. And so that could be one bucket, like the moderate longevity gains versus the, more extreme longevity gains. I don't think they're mutually exclusive. I think both are realistic, reasonable goals to have. I think my concern with the way this is presented is, I think it is a huge mistake to say that all resources should go towards indefinite lifespan. Why do I think that's a huge mistake? Because number one, I'm not sure that that's feasible, right? So again, I'm going to keep going back to this Weindruch and Walford experiment until somebody actually publishes data to shut me up, right? It's like I keep saying, why don't you do better than rapamycin before you start jumping up and down, right? So somebody go show you can do better than caloric restriction, I'll stop talking about it. But until you do that, I'm not sure there's any evidence that we can get indefinite lifespan extension. Nobody's done it in an animal. Nobody's showing what it's going to take to get there. So I think it's a good goal, but if we put all our eggs in that basket and we can't get there, then we've missed out on the opportunity to give people 20, 30, 40 years of additional health span and potentially lifespan, right? So I think we need to do both. And so I really don't like the framing that everything should go towards immortality or whatever you want to call it, right? Indefinite lifespan. I think that's a huge mistake, because we have real opportunities in this other space where there's clear line of sight on how we get. So I think we need to do both, would be my position. And I mean, we've talked about my efforts to do both here today, right? I think the million molecule challenge is a start towards getting beyond what anybody has ever accomplished before, which is a step towards indefinite lifespan extension. So that's how I view one place where we can put resources to actually potentially have an impact. But I also think at Octaspan and in a lot of the research that I've done on rapamycin, we have the opportunity to accomplish what I would call significant improvements in health span and lifespan today. So we should do that too, because there's a lot of people who we can help by doing that today. So I want to see us do both. And so I think we should take I guess the question would be, if we had somebody who was like, the longevity dictator who could say exactly how all the resources would be allocated, it's an interesting thought experiment. Like, what proportion of resources should be allocated into each of these buckets? And that's an interesting question. I don't know what the answer is. I haven't actually thought about that. Maybe I should. But I do think there are some technologies that kind of are in the middle, right? Like reprogramming, epigenetic reprogramming. It's in the middle, right? I think there's a real opportunities, and it's very likely that we can have what we would call moderate effects on health span and lifespan, at least for some people, using these reprogramming and regenerative reprogramming technologies. Now, obviously, there are some things that have to happen before we can do that in people, but I think everybody agrees that's likely that we'll get. But reprogramming could also be, the big advance that gets us closer to, indefinite lifespan. That's an unknown, right? And there's really no evidence yet that that's going to happen. But I think we all see a plausible biological model where you could have much larger effects on longevity through these reprogramming technologies. It's just very unclear whether that's going to happen. So I would say we should be investing in both of these areas, and particularly in these things like reprogramming that kind of fit in both. And I think indeed that's what we're seeing in the field. There's been a lot of resources clearly that have flowed into the reprogramming technologies because people recognize the fact that there is a more practical way to apply these technologies and the potential for these much larger impacts.
Cool. Thank you very much for the very thoughtful answer. Thank you. Anyone in the room have a?
Yeah. Yes, quite short one. Going back to dog longevity, I was thinking if Loyal will get the first drug approved, do you think that will lead to like canine longevity escape velocity? If they get
That's a great question. I've never actually honestly thought about canine longevity escape velocity. I don't know. I hope so. I hope so. I mean, again, I'm all for longevity escape velocity, right? I think as a concept, and would I like to see that happen in my lifetime or my dog's lifetime? Yeah, absolutely. Again, I think it's a huge leap to go from IGF-1 signaling or mTOR inhibition to longevity escape velocity, just given what we know in laboratory animals today. What I will say is, I think the dog aging project first with the rapamycin trial, Loyal now with their FDA trials, I think are stepping stones to seeing this idea of companion animals as a place where we can actually have a real impact on longevity and prove it in a time frame that is amenable to discovery. I think these are stepping stones to that model, and we will absolutely see more companies come into this space when and if Loyal is successful at getting conditional approval and hopefully eventually full approval for their interventions. And we're already starting to see more companies come into this space. And actually, I think that's where, again, Loyal and Celine, the CEO of Loyal, deserves a huge amount of credit for being a visionary and seeing this opportunity is having an immense impact on bringing for-profit entities and showing them a path to regulatory approval for a geroscience intervention. So that is very important, and I think it will start this cascade of more companies in the veterinary space or the companion animal space taking that similar model, which will have a feed-forward impact on human studies. And again, even though the Center for Veterinary Medicine at FDA is distinct from the regulation of human therapeutics at FDA, these people talk to each other. And so this is going to have an impact on the way that FDA thinks about regulation of geroscience interventions for human use as well. So I think this is one really important piece of the puzzle here as we start to move towards more attempts at regulatory approval for geroscience interventions.
Thank you.
Yeah, it's a short question, but I also want to make that you have your great podcast, Matt, also on Spotify. Since we're in Sweden, that could be good. I can also follow you there. So my question is regarding the preventive health screenings and your view on them in general. I mean, there are some large meta-studies that has been done previously in 2019. It's a large one that looked at what is the long-term benefit of doing health checkups and this preventive health screening. And the outcome at that point in time when this followed people over a long time, was that there were a very limited effect on terms of morbidity and mortality. So what do you think? And this is kind of old style, perhaps health check. What is your view on health screenings in general, and what do you think the shortcomings were from those type of health assessments?
Yeah, so I mean, I think those kinds of long-term epidemiological studies obviously are very challenging for a variety of reasons. Peter Attia actually had an episode recently. I wish I could remember the specific name of the episode, but where he kind of he addressed this question in a very specific context of I think it was probably cancer screenings, breast cancer screenings, and why it is that you sometimes get these outcomes where there is no large effect on mortality from those specific types of screening. So it's probably too long to get into a very detailed answer, but I will just say with the breast cancer screenings as an example, when you're screening for only one disease, again, everybody in this call should recognize the fact that individual disease care doesn't have a large impact on population mortality. If we could cure every form of cancer today, if we had a test that could identify every form of cancer before it started and we could cure it, that would get us 3 years average life expectancy for a typical 50-year-old woman. So it's very hard from screening for one type of disease to get any significant impact on mortality, especially if it's only one subtype of cancer. So I think that's part of the equation. My view is, so the downsides to extensive screening are cost and false positives, in my view. And those are real. I'm not trying to minimize them. But the benefits are immense, right? If you can detect disease or pre-disease early and get people on a better health trajectory, both from preventing the disease, but also from a behavior modification perspective, which is maybe equally as important. There's no question in my mind that that is valuable. What will the impact be on lifespan? I don't know. I don't think there's any way we can know. I could speculate 5 years, but I really don't know. But the impact on health span, I think, is going to be outsized. I would guess we can probably get 10 to 20 years of health span, at least for the average American. The other thing I'll say, because I know we're short on time, is just in our program, so we've got about 100 people in our corporate health span program right now. We have a lot of success stories. We have, and this is a pretty typical cross section of middle class, at least Pacific Northwest America people. We've detected a lot of undiagnosed diabetes, pre-diabetes, and gotten people on a better path. Will they maintain it for the next 20 years? I don't know. If they do, I guarantee you we got those people 10 or 20 years of health span. So at the individual level, I think that this type of preventative healthcare is immensely important, and we can have very large impacts on health quality for many people over the next several decades. So I am a huge proponent of preventative healthcare, of which I think that pre-screening is an important part. I do think we want to be careful, though, and not and be thoughtful about cost and false positives. False positives can create a lot of stress for people. So I'm not suggesting that we pre-screen everything. I think we need to be thoughtful about that. But in general, I think there are real opportunities.
Thank you.
All right, that's a wonderful answer. We are out of time. Yeah, if do you have so just to wrap up, is there anything, Matt, that you sort of would like to highlight, or what's on top of your mind right now, or anything like a special message that you want to get out that perhaps we could help you with?
Oh boy, honestly, I don't know. I think I pretty much hit most of the things that I am most enthusiastic and excited about. I guess the thing I would just end with, and I know I sometimes come off as like a grumpy, grumpy guy. I'm not. Like, I am really very, very optimistic about the direction the science of the field is going, the clinical application of the field. So I guess I would just say, don't be misled by the fact that I often tend to take a very serious and critical eye towards much of what's going on in the field. I do that because I think that it's important to have that balancing voice. But in general, I am very, very optimistic about the direction things are going. I think, like I said, if you think about the shape of a hockey stick, we're at a hockey stick moment in the field where we're kind of like right here, and it's going to go like this. And so I think we all want to be enthusiastic and excited, but we also need to have serious voices so that as we start to go into this exponential increase in interest, that we don't go off the rails. And so I'm trying to play a role in helping us, keep this thing on track going forward. But it's a great time to be a young person in this field. So you guys are, you guys are really well positioned, and I'm excited to see where things go.
Oh, that's wonderful. So optimism and skepticism both. Sounds lovely.
And OptiSpan podcast is also good to listen to.
Thank you.
Awesome. All right, with that, we're gonna wrap up this this talk. And Matt, thank you so much for taking the time. We really appreciate it. It helps us a lot to
My
build.
pleasure.
Thank you so much.
You got it. Anytime.
All right. Have a
Take care, everyone.
Bye-bye.